Hey guys, today we're looking at volume of pyramids and cones. So let's dive right in to the formulas. So volume of a pyramid is going to be a third of the base times height, or base times height divided by 3, and that's typically how I write it, but you can use 1/3 times if you like that better. B is the area of the base, H is the height. So notice with this pyramid, we're not using slant height. Slant height only is used on the surface area. So find the volume of this pyramid. We need the area of the base, and we need the height. Our formula is base times height divided by 3. So area of the base, it appears we have a square. So side squared, so we have 10 squared, or 100, and then the height is 12. So if I plug this in, I get 100 times 12 over 3, or 1200 over 3, which is 400 yards. We're talking volume, so cubed. Okay, so Cavalier's principle at work again. Even though this is slanted, we're still going to use that vertical height. So find the volume of this pyramid. Again, we're going to use volume is area of the base times the height divided by 3. So we need to find the area of the base. We know the height is 10. Now, we have a hexagon base. So, we're going to have to use area of a regular polygon. We're going to use A equals AP over 2. All we have there is that side length. So we're going to have to do a little work. So I'm going to draw out a triangle over here. Now be careful, because if I'm drawing only half of that triangle, then this is actually 2, not a side of 4. I need to know the apothem. So I need to find that central angle, 360, divided by the number of sides. So I get 60 degrees, but that's that whole central angle. So this is 30 degrees. So now opposite is 2, adjacent is A, opposite and adjacent are tangent. So I have tangent of 30 is equal to 2 over A. I'm going to cross multiply, so I get 2 equals A times the tangent of 30. I'm going to divide by the tangent of 30. So A is approximately 2 divided by the tangent of 30. Gives us 3.46. So the apothem is 3.46. Now I need to multiply by the perimeter, which I haven't found. So perimeter would be a side length of 4 times 6 sides would be 24. So by 24 over 2. So 3.46 times 24 divided by 2 is about 41.52. So now I have 41.52 for the area of the base times a height of 10 divided by 3. And I get approximately 138.4 inches cubed. And it says to round to the nearest 2 decimal places, but depending on where your significant figures are and how you rounded to begin with, you may only end up with 1 decimal place there. That's okay. Alright, volume of a cone is just like when we're dealing with volume of a cylinder that we're doing base times height over 3, but we know our area of the base is always going to be pi r squared. So we have pi r squared times the height divided by 3. So find the volume of this cone. So V equals pi r squared h over 3. So we get pi times the radius squared times the height over 3. I guess we're still with an equal sign. We haven't done anything to approximate just yet, so I'll use a normal equal sign here. Okay, so then if I multiply all that out except the pi, I get 81 pi feet cubed. Then if I multiply that pi in there, I get 254.47 feet cubed. Okay, one last one. Find the volume of this cone. Round your answer to 2 decimal places. Okay, so we're going to use V equals pi r squared h over 3. So what I notice is we have the height, but I don't see our radius. I do see a degree measure there though. So looking at this triangle, if I want to find this radius r, I'm going to need to use some trig. So I have opposite is 12, adjacent is r, so that would be tangent of 62 is equal to opposite over adjacent. And I'm going to cross multiply. So I get 12 is equal to r times the tangent of 62. Divide by the tangent of 62. So 12 divided by the tangent of 62, r is approximately 6.38. And then I'm going to plug that in. So I get V is approximately pi times 6.38 squared times a height of 12 divided by 3. Now I've already rounded, so there's no reason to be exact. So I get 511.51, and my label is meters cubed. Alright, that is it for today. So if you have questions, feel free to come see me. Have a great day, and I'll see you in class.